So now we look at the gradient of a line segment. We look at a gradient of a line segment. So what we are told is that the gradient of a line segment, it is the steepness or the slope of a line. The steepness or the slope of the line. You know the slope like this, the steepness. So we have, if the line slopes to the right, meaning sloping like this, to the right like this, like the way we are seeing this line, the gradient is positive. Again, if the line slopes to the left, the line slopes like this, how will be the gradient? The gradient is negative. Normally these 2 points normally fall when you are dealing with the line on a diagram or on the Cartesian X or Y plane. What I mean is, if you have the Cartesian X or Y plane, we have X-axis and Y-axis, then we are finding the gradient of a line like this. This line is sloping to the left. The line has sloped to the left. So the gradient there will be positive. Rather will be positive. Will be negative, sorry. Will be negative. But if the line slopes like this, or the line is like this, the gradient there, because it's sloping to the right, the gradient is positive. How? If you are also dealing, maybe we are dealing with the quadratic equation, then there is a tangent there. Of course, we are going to look at this one, mostly when we deal with the calculus, where we have the normal and the tangent. So, the gradient here is because this one is sloping, it's the same as this one, the gradient is positive. But if the line is like this, let me say this is my tangent, which is touching this curve there. So the gradient there will be negative. What else do we have? Now we have a formula which is used to find the gradient when you have been given 2 coordinates. Or I mean 2 coordinates of 2 points. You have been given the 2 points, you can find the gradient by using the formula. Now the gradient, the symbol we use is m. So I'm going to say gradient is equal to the change in y divided by or over the change in x. What does it mean when you're talking about the change in y? Remember I've looked already at the change. When you say y2 minus y1, it means we are finding the change in the 2. So the change in y can be written as y2 minus y1 over the change in x, which is x2 minus x1. Now let us note the following. Note a horizontal line. I can even put it, a line which is in the form of like this. A horizontal, the x-axis. The horizontal line, has a gradient of 0. The horizontal line has got a gradient of 0. But the vertical line, for example, the y-axis, the vertical line, a line like this. So the vertical line has an infinity or undefined gradient. Has an infinity or undefined gradient. This is what we have when we have the horizontal line and also the vertical line. So this is the introduction. Let us now look at some examples. So we have 4 questions here. We have question number A, question number B, question number C, and question number D. We'll look at 2 questions, then the rest will be done by you and no one else, by you. So now, I'll do question number 1. Let me do question number B, and also question number D. So question number B, we are looking at the gradient of QR. So I will say this, we are going to say gradient of Q and R is equal to y2 minus y1 over x2 minus x1. What is the coordinates of Q? Q is negative 3, 5, and the coordinates of R are 5, 2. This one we call it x1, y1, we have x2, y2. So we are going to have 2. This is our y2. We have minus 5 over, we have 5 for x2 minus negative 3. So this will be 2 minus 2, I mean 2 minus 5. We have negative 3. Then 5 minus negative 3, it is the same as saying 5 plus 3. So the answer is 8. And this marks the end to this question. The answer is 3 over 8, or negative 3 over 8. Now, the thing is, it does not matter which one is your 2, which one is your 1. Someone may say this one will become your 2, meaning x2 and y2, this one becomes your 1. There's no problem. You can still do that. The answer will still find the same answer. We go to the next question. The next question is, I'll do question number D. Now, the reason why I've left it here, because even if it's a fraction, just leave it in a form of fraction. If at all there's no common factor. Again, 8, of course 8 can go into 3, but it will still leave a remainder. Because 8 into 3 to go 0.3, okay, to go 0.3 plus. We have a lot of decimal numbers. So let's try D. D is PS. So the gradient of PS is equal to y2 minus y1 over x2 minus x1. So it's up to us to choose which one will be our 2 and our 1. Which one will be our 2's and our 1. So in this case, I'll change now. I'll say this one is my 2. This one is my y2. This is my x1. That is my y1. Now we are going to say the gradient itself, or M, is equal to, what is our y2? It's negative 4 minus negative 3. We have our x2 is negative 6 minus 7. So we are going to have, this is same as saying negative 4 plus 3 over negative 6 minus 7. So we have this one, it will be 1, I mean negative 1 over, what is this? What is 7 or negative 6 minus 7? Negative 6 minus 7, the answer is negative 13. Therefore, our gradient is 1 over positive 13. I mean positive 1 over positive 13, because negative divided by negative, it gives us positive. So this marks the end to these two questions. We are remaining with question number B, and I mean question number A and question number C. So find time, you work out these two questions. Thank you.